The population P of a small town after T years can be modeled with this population as a function of time, where T equals 0 represents the beginning of this year. So write an expression for average rate of change using T equals 0 and T equals 8. So T equals 8 to T equals 8 plus some incremental of H. Okay, so that's going to be P at 8 plus H minus P at H. So P at 8 over 8 plus H minus 8. Now this here, you'll see this in calculus, right? This is called a differential quotient. But for now, I'm just going to simplify this. Okay, so this is going to be 0.5 okay, and then just plug in 8, right? Okay. Now the key to simplifying this is to group the like terms. This and this is a like term. This and this is a like term, and these two will cancel each other out. Right? 1200 minus 1200. So let's put the like terms right beside each other. 0.5 minus 0.5, 158 plus H minus 150 times by 8 all over H. Okay, you can factor out a minus 0.5 from the first two terms, and you get 8 plus H cubed minus 8 cubed. Here you're going to get a positive 150 times by 8 and then a minus 150 times by 8. So that's going to cancel out. And we're going to be just left with 150 times by H. And this right here, this is in the form of the differences of cubes. And we have a formula for that. Okay, so you can use this formula right here to factor this instead of expanding. The factoring process will clean up this a lot better. Right, so A minus B is 8 plus H. That's A, and 8 is B. So it's going to be 8 plus H minus 8. Note that that's just gonna equal to H. Then we have 8 plus H squared plus 8 times 8 plus H plus 8 squared. The nice thing here is that that's H, that's H, it will reduce with that. So what we have left over is 0.5 bracket that. Stop my simplification right there.